Welcome to Potty, May 23, 2026. Here's a question that I think reframes everything we're going to talk about today. What if the most important thing Google announced at I/O 2026 wasn't a model at all? Everyone's focused on Gemini Omni, on the multimodal demos, on the benchmark comparisons, and those things matter. But there's a quiet infrastructure move underneath all of it that I think is actually more strategically significant, and it connects to a platform battle that's starting to look a lot like the browser wars of the early 2000s. We're talking about who controls the layer that AI agents run on, and Google just made a very deliberate set of moves to own that layer.
Okay, you've got my attention immediately, because I went into looking at the I/O 2026 coverage thinking this was going to be another Google shows off impressive demos, announces a bunch of products situation, and honestly, there's plenty of that. The complete recap I was reading lists Android 17, Android XR glasses, Google Books, AI mode search agents, Gemini Spark, 50 plus more updates. It's a lot, but you're saying there's a through line here. That's more than just product launches?
There is absolutely a through line, and once you see it, you can't unsee it. Let me set the stage properly because the context matters a lot here. Google I/O has always been Google's platform strategy announcement. Historically, it's been about search, Android, cloud. Since 2023, it's increasingly become Google's competitive signal to Microsoft, OpenAI, Anthropic, Meta. But here's what's different about 2026. The industry has basically settled the question of whether large language models are useful. That debate is over. What the industry is now fighting over is the next layer, how AI integrates into workflows, how it replaces software interfaces, and critically, how it runs efficiently at massive scale. Those are the three battlegrounds at I/O 2026, and Google has a move on each one.
So walk me through Google's specific position here, because I think it's easy to just see them as the big search company doing AI stuff. But you're suggesting their position is actually structurally different from, say, OpenAI or Anthropic. What makes Google's setup unusual in this landscape?
Right, so this is actually really important background. Google is simultaneously a model developer, a chip designer, a cloud provider, and a consumer platform. That's a combination that pure-play AI labs simply don't have. OpenAI makes models and has some products surfaced through ChatGPT, but they don't design chips and they run on Microsoft's infrastructure. Anthropic makes models, period. Google is all four things at once. The leverage that creates is enormous, but so is the coordination complexity. When you have that many moving parts, executing coherently across all of them is genuinely hard. And I think one of the more interesting things about I/O 2026 is that the story feels more vertically integrated and coherent than it has in prior years. The chips, the models, the agent platform, the consumer surfaces. They're actually connecting into a single narrative this time.
Okay, so let's get into the actual announcements. 2 models and a major hardware move, as I understand it. Start with Gemini Omni because that name alone is doing a lot of work. What actually is it, and what does world modeling mean? Because Google is using that phrase, and I want to make sure I understand what they're claiming versus what's marketing language.
So, the official framing from Google's keyword blog is that Gemini Omni can create anything from any input, starting with video, and it's described as a leap forward in world understanding, multimodality, and editing. The world modeling language is actually a term of art that comes from robotics and reinforcement learning research. It's not just marketing. In that literature, a world model is an internal representation that allows a system to simulate future states, rather than just respond to current inputs. Think about the difference between a chess engine that evaluates the current board position versus one that can mentally simulate 10 moves ahead and reason about what the board will look like. Applied to a multimodal foundation model. World modeling suggests the system has richer causal and spatial representations. It doesn't just translate between modalities. It actually understands the relationships between objects, how they move through time, cause and effect in physical scenes.
Wait, hold on. So when they say starting with video, that's not just a demo choice. That's actually pointing at something architecturally meaningful? Like video is the hardest version of this problem.
That's exactly the read I have. Video is temporally dense. Every frame is a snapshot, but the meaning is in how those frames relate to each other over time. If your model genuinely understands video at a deep level, it means it's tracking objects across time, understanding motion, understanding what's likely to happen next. That's a much harder problem than understanding a static image or translating text. And here's what most people get wrong about this. They think multimodal just means the model can accept different types of input. But the interesting question is whether the model has a unified internal representation that captures meaning across modalities, or whether it's essentially doing separate processing and stitching results together. The world modeling framing suggests Google is claiming the former, a unified spatial and temporal understanding. Now, I want to be careful here. Google's framing is not independently validated third-party evaluation. It's their positioning, but the conceptual direction is significant, and it connects to some longer-term bets that make a lot of sense when you look at the full I/O announcement picture.
Okay, and those longer-term bets, you're talking about the Android XR glasses, robotics, physical AI? Because I noticed that's in the announcement list too. And it seems like it might not be a coincidence that they're announcing a world model and AR glasses at the same conference.
Exactly right. And this is where the strategic coherence I mentioned earlier really shows up. If you have a model that genuinely understands spatial and temporal relationships in the physical world, that model becomes dramatically more useful for AR overlays, for robotics, for any application where the AI needs to understand what's happening in the real world and what's likely to happen next. Google also has infrastructure advantages here that are easy to overlook. Maps, Street View, and YouTube's video corpus. Think about what YouTube represents as a training resource for a model trying to understand how the physical world works. It's basically the largest collection of humans demonstrating how to do things ever assembled. That's a genuinely unique asset. So the Gemini Omni announcement, the Android XR glasses, the robotics direction, those are not separate product announcements. They're facets of the same long-term bet.
Okay, so that's Gemini Omni. Now, let's talk about Gemini 3.5 Flash, because this one is positioned very differently. It's not about the most capable model. It's about the most efficient model for a specific use case. And I want to understand what frontier intelligence with action actually means in practice.
So Gemini 3.5 Flash is described by Google as the first in their latest model family, combining frontier intelligence with action. And the action framing is key. This model is explicitly optimized for agentic use cases. Here's why that distinction matters. In a single-turn chat context, what you care about most is response quality. Is the answer accurate? Is it nuanced? But in an agentic context, where the model is planning multi-step tasks, calling tools, managing state across a session, the calculus is completely different. Latency and cost per call become critical. Here's a concrete way to think about it. Imagine an agent that's planning a block party, which is actually the demo Google showed with Gemini Spark. That agent might need to check a calendar, query a Maps API, look up vendor availability, draft messages, coordinate timing across multiple apps. Each one of those is a model call. If each call costs too much or takes too long, the whole system becomes unusable. So Gemini Flash 3.5 is engineered for that environment. High throughput, low latency, cost efficient at scale.
And there's a reliability issue here too, right? Because I was reading about how agentic systems compound errors across steps. Like if a model fails 10% of the time on a single step, that gets really bad really fast when you're chaining multiple steps together.
That's one of the most underappreciated challenges in the agentic AI space right now. If a model has a 10% error rate on a single step and you chain 5 steps together, your probability of completing the whole task successfully is roughly 60%. That's not a usable product for most applications. So accuracy at the individual call level matters enormously in agentic contexts, not just speed and cost. This is why the Flash 3.5 positioning is interesting. They're not just saying it's cheaper and faster, they're saying it maintains frontier-level intelligence. Whether that claim holds up under independent evaluation is a separate question. And I want to be clear that the benchmark comparisons you see against Claude Opus 4.7 and GPT 5.5 right now are largely Google's self-reported positioning, not third-party validated results. The market will sort that out over the next few months as developers actually use these systems. But the design intent, efficiency without sacrificing accuracy, is exactly what the agentic use case demands.
Okay, so now the hardware announcement, because I think this is the one that might be most underreported in the mainstream coverage. Google announced their 8th generation TPUs as 2 distinct chips, TPU 8T for training and TPU 8I for inference. That feels like a significant architectural departure. What's the story here?
This is genuinely the announcement I find most strategically interesting, and you're right that it's underreported. Prior TPU generations were more general purpose. You'd use them for training, you'd use them for serving. They were flexible. The 8T and 8I split makes the specialization explicit. And there's a really deep reason why training and inference have different hardware requirements. Training requires dense matrix operations at high precision with frequent weight updates. You need high bandwidth memory, fast interconnects between chips, the ability to do lots of synchronized updates across a huge cluster. Inference at scale is almost the opposite problem. You have fixed weights, you need to serve them to millions of users simultaneously, often at reduced numerical precision. And what dominates is memory bandwidth per compute operation and power efficiency. Those are genuinely different optimization targets. Specializing silicon for each workload can yield 2 to 4 times efficiency gains over a general-purpose design. And at Google's scale, that translates to billions of dollars in infrastructure cost savings.
Wait, 2 to 4 times efficiency gains? That's not incremental. That's a massive difference. And you mentioned this mirrors moves by Microsoft and AWS too. So this is becoming a pattern across the whole hyperscaler industry?
It really is a pattern, and that convergence is a signal worth paying attention to. Microsoft has Maya 200, which is inference for AWS has Trainium for training and Inferentia for inference. They actually pioneered the naming convention that makes the specialization explicit, and Google is now doing the same thing with the T and I suffixes on TPU 8. When 3 of the largest cloud providers independently arrive at the same architectural split, that's not coincidence. It's evidence that the engineering trade-offs genuinely demand specialization. And here's the strategic dimension. These chips aren't just for Google's internal use. TPU 8T and 8I are Google Cloud products available to external customers. So enterprises and AI labs, training or serving models on GCP, now have workload-optimized options that could meaningfully reduce their costs. That's a competitive lever against AWS and Azure in the AI infrastructure market. The naming convention, T for training, I for inference, is also clearly designed to be legible to cloud buyers who are making procurement decisions.
So let's talk about the Agentic platform layer, Anti-Gravity 2.0 and Gemini Spark, because this feels like where the browser wars analogy you mentioned at the top comes in. What's the actual strategic play here, and why does it matter who owns the orchestration layer?
So Anti-Gravity 2.0 is Google's new agent platform for developers, and Gemini Spark is the personal AI agent in the Gemini app. The Keynet coverage frames Gemini Spark as being able to help plan a block party by working across apps, which sounds like a fun demo, but the mechanism underneath it is what matters. Gemini Spark is coordinating across multiple applications to accomplish a multi-step task. That means it needs cross-app permissions, it needs persistent context, it needs to understand the state of multiple systems at once. Now think about what that means for developers building on Anti-Gravity 2.0. If you build your agent workflow on Google's orchestration platform, your switching costs go up significantly over time. Even if a competitor releases a better base model next year, migrating your agent infrastructure is expensive and risky. That's where developer lock-in accumulates. Not at the model level, but at the orchestration layer. And Google controls the orchestration layer, the OS layer through Android, the browser layer through Chrome, and the search layer. That's a very powerful stack.
So if you're watching this in 2026, you're going to look back and remember exactly when this shifted. When AI stopped being a feature inside apps and started being the layer that coordinates between apps. That's a genuinely different paradigm, but I want to push back a little. Apple is doing something similar with Apple Intelligence and cross-app coordination. Microsoft has Copilot deeply integrated into Windows and Office. Isn't Google just one of several players making the same move?
That's exactly the right pushback, and the honest answer is yes. Google, Apple, and Microsoft are all making this move simultaneously, which is precisely why I think the browser wars analogy holds. In the late 90s and early 2000s, every major tech company understood that controlling the browser meant controlling the user's gateway to the internet. Today, every major platform company understands that controlling the agent runtime, the thing that has your persistent context, your cross-app permissions, your trusted identity, means controlling the user's gateway to AI-mediated computing. The outcome of the browser wars wasn't determined by who had the best browser on day one. It was determined by who had the deepest OS integration, the most trusted default position, and the best developer ecosystem. Google won that eventually with Chrome, but it took years. The agent wars are going to play out similarly, and the outcome may hinge less on model quality than on which platform has the most trusted permission model and the deepest OS-level integration. That's a very different competition than whose model scores best on benchmarks.
Okay, let's get to predictions, because I want to hear your forward-looking read on where this all goes. You've been pattern matching across the hardware specialization trend and the Agentic platform fight. What are the non-obvious trajectories you're seeing?
The first one is about hardware economics, and I think it's genuinely underappreciated. When you look at the pattern of Google doing TPU 8T and 8i, Microsoft doing Maya 200 as inference-focused AWS, with Trainium and Inferentia. The direction this points is that, within 18 to 24 months, inference-optimized chips become the dominant cost center in AI infrastructure budgets, displacing training chips. Think about the math. Right now, a lot of the compute investment is in training new frontier models, but as the industry shifts from building new models to actually serving billions of agentic queries at scale, all those Gemini Spark block party planners running simultaneously, the inference workload explodes. Training a new frontier model is a one-time cost that gets amortized. Serving billions of queries every day is a recurring, scaling cost. I think we're heading toward a world where inference efficiency is the primary competitive moat in cloud AI, and training compute gets commoditized. This is pattern matching from the hardware signals we're seeing, not a first principles forecast, but the convergence is hard to ignore.
That's a really interesting inversion. The thing everyone's been focused on, training compute and frontier model scale, becomes less important. And the boring-sounding inference efficiency problem becomes the real moat. What's the second prediction?
The second one is more speculative, and honestly, might be the contrarian take that doesn't get enough airtime. Everyone assumes the agent wars will be won by whoever has the best AI model. I think that's wrong. Here's the thing. Gemini Spark, Apple Intelligence, Microsoft Copilot, they're all going to be reasonably capable. The models are going to converge toward good enough for most use cases. What won't converge is the permission model. When an AI agent wants to access your calendar, your email, your location, your payment information, your health data, users are going to be extremely selective about which agent they trust with that access. And trust is not a technical problem. It's a platform relationship problem. The agent that wins is the one whose parent platform already has the deepest trust relationship with the user. That's a profound advantage for whoever has the most embedded OS. And I want to acknowledge, this extrapolation could shift significantly based on regulatory responses to AI agents accessing personal data. There are real questions about consent, data use, and liability that regulators in the EU and elsewhere are going to have strong opinions about. The regulatory environment could completely reshape which permission models are even legally viable.
That regulatory angle is really important, and I'm glad you flagged it. Because the Gemini Spark demo, coordinating across apps to plan a block party, that sounds delightful in a keynote. But the moment you actually think about what permissions that requires and who has access to that data, it raises a lot of questions. What should listeners be watching for in the next few months to track whether these announcements are delivering on the narrative?
A few concrete things to watch. First, developer adoption of Anti-Gravity 2.0. Not the launch announcement, but whether serious AI builders are actually building production agent workflows on it 3 to 6 months from now. Orchestration platform adoption is a lagging signal, but it's the real one. Second, independent benchmark evaluations of Gemini Flash 3.5 against Claude Opus 4.7 and GPT 5.5 from third parties, not Google's self-reported positioning. The performance claims matter, but they need external validation before you can rely on them for infrastructure decisions. Third, watch for any regulatory moves in the EU around agentic AI and cross-app data access. That's going to be a constraint that shapes the whole category. And fourth, honestly, go watch the Google I/O 2026 developer keynote recap and the full I/O recap on YouTube. They're listed in the coverage, and they'll give you a sense of how Google is actually presenting this to developers versus how the press is covering it. The framing differences are often revealing.
Okay, let's bring it home. We came into this episode with the question of whether Google I/O 2026 was just another product launch cycle or something structurally different. Where do you land?
Here's where I land. The strategic coherence at I/O 2026 is more legible than it's been in prior years, and that matters. Gemini Omni's world modeling ambitions connect directly to Android XR and physical AI. Gemini Flash 3.5's efficiency for agents design connects directly to the Anti-Gravity 2.0 platform play. The TPU 8T and 8I split connects to Google's ability to offer workload-optimized cloud infrastructure that competitors will struggle to match. These aren't separate product announcements. They're facets of a vertically integrated AI stack story. Whether execution matches the narrative is genuinely uncertain. Google has a long history of impressive announcements that don't fully materialize. But the stack they're describing, custom chips running efficient models powering autonomous agents across every Google surface, is the right stack to be building if you believe the agentic era is real. And based on everything we're seeing, the agentic era is very real.
I love that framing. The stack is right, execution is the open question, and I think that's actually the most honest thing you can say right now. The pieces fit together in a way they haven't before. Whether Google can actually deliver on all of it simultaneously is a separate bet. Sam, this was genuinely one of the more clarifying conversations I've had about what's actually happening at the infrastructure and platform layer underneath all the AI noise. Thank you for going deep on this.
The thing I want to leave you with is this. We started by asking whether the most important announcement at I/O 2026 was even a model. And I think the answer is no. It's the claim that Google is building the layer that all the models run on, the layer that mediates between AI and the rest of your digital life. That's the agent runtime. That's the new browser. And the race to own it is just getting started. The companies that figure out the trust and permission model for that layer, not just the capability, are the ones that are going to define computing for the next decade. Go dig into the primary sources, watch the developer keynote, read the keyword blog post, and form your own view. We'll see you next time.